It's one small step for man, one giant leap for mankind.
The next big thing is here.
Call it the iPhone.
Technology has taken us places we've only dreamed. Technology has the power to unite us.
These ingenious companies wouldn't even exist, or maybe even thought of, if it weren't for Jack Kilby and his monolithic legacy.
If you look back to the first great wave of American innovation, I'm talking about Thomas Edison, Alexander Graham Bell, Henry Ford, engineers who changed the daily life of the world with a good idea. They were global heroes. Jack Kilby changed the daily life of the world just as spectacularly as Thomas Edison did and Henry Ford did.
Invention of the monolithic integrated circuit, the microchip, laid the foundation for the entire field of modern microelectronics.
Jack Kilby was one of the greatest innovators of the 20th century. A leader in electronics engineering, he left a legacy of technological advancements. His achievements left a mark on almost all of modern technology. His main invention, the microchip, also known as an integrated circuit, sparked a new beginning to lead a legacy of many new and improved inventions, including the pocket calculator, missile guidance system, and more indispensable devices that shaped modern society. Jack Kilby was born in Great Bend, Kansas. Growing up with a father that strived as an electrical engineer, Kirby worked alongside his dad. Jack's curiosity of his dad's electrical distribution plants enticed his career in technology. He ventured on towards his legacy by studying electrical engineering in the University of Illinois for his bachelor's degree and the University of Wisconsin for his master's degree. When he was done, he went back to Great Bend, Kansas, and was put in charge of designing miniaturized electronic circuits. In the beginning, in 1958, he moved from Great Bend, Kansas, all the way to Dallas, Texas, and joined Texas Instruments. Like many inventors, he set out to solve a problem. In this case, the problem was called the tyranny of numbers, said his company.
Wanted to work on what was then called circuit miniaturization, and chose TI as one of the more promising places. They were really the only one that offered to let me work full-time on the kind of thing I wanted to do. So since it had to be semiconductors, I began to think about how much you could do with semiconductors and realized that you could make all the circuit elements that you needed that way. Well, the initial process was mostly in thinking about it, sketching things on paper, not much physical effort for several months. At the end of that period, we actually began to try to build something, and the first circuit was finished in September.
In that same year, when most senior workers left for the traditional 2-week vacation, the monolithic legacy began.
It was a relatively simple device,
said T.I. For what he made was only a transistor, resistor, and other components etched onto a small 7/16 by 1/16 inch of germanium, which is the size of a paperclip. He called it the integrated circuit. In a presentation convention for TI and other companies' inventions and innovations, he brought along his IC, or integrated circuit. When no one believed this would happen, he used it to project a never-ending sine curve on a screen.
Many people do not realize today that the ultimate worth of the integrated circuit was not universally recognized in the early 60s. It was viewed by many serious thinkers with great skepticism. I remember at a conference in Seattle, and I think it was 1965 or 66, I was almost hooted off the stage for having made some positive comments about the future of integrated circuits.
Soon, his invention flooded the U.S. with overwhelming persuasion. The IC became the next big thing in the world of technology. It proved to lead a potent legacy in many inventions led by Jack Kilby and others, starting in the most nervous time between the U.S. and the Soviet Union, the Cold War, with the United States' first successful nuclear missile, the Minuteman. During the Cold War, when the U.S. was fabricating the Minuteman I, TI figured out that the IC was the key for success for the Minuteman's guidance computer. So they made a mission, co-led by Jack Kilby, and tried to convince the missile maker, Autonetics, that ICs can be useful. After lots of persuasion from TI's manager, Charles Phillips, and Jack Kilby, other TI workers, and some support from the U.S. Air Force, they finally convinced Autonetics.
The lucky thing that happened was the Minuteman missile. They had to go to miniature electronics. What was more ideal than an integrated circuit? So the Air Force sponsored the integrated circuit. So the Air Force people up in Dayton are responsible really for commercializing integrated circuits. Because with that background, we were able then to develop farther along and to show it really was practical.
In Minuteman II, the IC proved to be a major improvement, allowing missiles to actually scare the whole world. This missile's guidance computer obtained 2,000 ICs, so it had improved range, much better accuracy, and was 50% lighter. This drastically changed the convenience and reliability of missiles. And obviously, in 1964, Minuteman II successfully launched and landed in the correct location, allowing the U.S. to be a much more powerful country, leading another legacy in nuclear warheads. Earlier in the 1960s, former President Pat Haggerty discussed the invention of a handheld calculator when Jack Kilby was on a vacation trip. Because of the gargantuan calculators of that age, which were the size of a desk, making it hard for architects and other field scientists to calculate things out of the lab. In 1964, Dean Toombs, head of a semiconductor R&D, formed a team consisting of Kilby, Jim Van Tassel, and Jerry Merriman to develop a calculator that would fit in the palm of the hand, yet powerful enough to perform a basic math function. With great leadership from Jack Kilby and his great abilities in technology, in December 1966, the Caltech calculator was made. With 18 keys, this calculator was only able to do basic math functions like addition, multiplication, division, and subtraction. With this calculator, architects and field scientists were able to easily calculate measurements, and scientists can solve things easily wherever they want to. Another feature this calculator incorporated was another one of Kilby's great inventions, the thermal printhead. The thermal printhead was one of Kilby's ingenious ideas in which he led the whole project. The thermal printhead was made to print on a special heat-sensitive paper like grocery bills, incorporating the IC so now you can print things from a digital device. And after solving a lot of problems, Jack Kilby led perfectly so that the group created a perfectly functioning printer that printed on heat-sensitive paper at a speed of 400 words per minute, or 40 characters per second. This invention would lead a legacy of all the thermal printers made now. So in 1965, another one of Kilby's ingenious inventions was born. As a brilliant inventor and engineer, Kilby has made many capacitic contributions which led to honor and respect from many people. As a result, Kilby was inducted in the National Inventors Hall of Fame and the Engineering and Science Hall of Fame. Jack Kilby was awarded the 2000 Nobel Prize in Physics, and over his lifetime and his career, Jack Kilby had dozens of patents and established the Jack Kilby International Awards Foundation, leading a legacy for many others who strive to be as great as he was. As a great inventor, he held many patents and many great inventions. Without his most widely known invention, the microchip, you may not even have that phone or even hear this first of all. His inventions, like the microchip, inspired and was used in many new inventions, such as the famous computer, printer, television, phone, camera, car, electric oven, microwave, traffic lights, and many other appliances and electronics. A legacy of technological advancements from one of the best leaders in electronics engineering.